Number 1 asks you to select all of the expressions equal to 5 squared. So we want, or 5 to the second power. Remember what 5 squared means. It means that it's 5 times itself. So we're going to select this one. And we're going to select 25 because 5 times 5 is 25. Number 2 asks you to write 1/6 to the 5th power in expanded form. Expanded form means you're going to write it big. You're going to write it longer. So we're going to write out 1/6 times 1/6 times 1/6 times 1/6 times 1/6. And that's an expanded form. You can use the dot if you want for multiplication instead of the parentheses. I just don't really like it that much. Number 3, what is the value of this expression? They're asking you how much is it worth? What's the value? So if we write it in expanded form, we have -2 times -2 times -2, which tells us -2 times -2 is +4 times -2 equals -8. So -2 to the 3rd power in parentheses is -8. For number 4, they ask us to write the simplified version of the expression 2 to the 8th divided by 2 to the 3rd. So what we want to do, we have several options. We can think about what happens if we wrote them all out and canceled things out. So we have in our numerator 8 2's and in the denominator 3 2's. There are extra 2's in the numerator, and there are 5 of them, so our answer is going to be 2 to the 5th power. Also, the rule for dividing powers is to keep the base and subtract the exponent. So 8 minus 3 gives us 5. So it would answer either way. Our answer would be 2 to the 5th power. Number 5, using exponents, what is the simplified form of 14x to the 6th divided by 7x squared? So we're going to do numbers divided by numbers. 14 divided by 7 is 2. X to the 6th divided by x to the 2nd power. We have 4 extra x's in the numerator, so we're going to have x to the 4th power. So everything in the denominator is canceled out. Our answer is 2x to the 4th power. Number 6, using exponents, what's the simplified form of the expression 5 to the 3rd times 5? So we keep the base and add the exponents. We need to remember that 5 is 5 to the 1st power. So 3 plus 1 gives us 5 to the 4th power as our answer. Also, if we wrote it out, we'd have 3 5's times 1 more gives us 5 to the 4th. So you have 2 different ways of getting the same answer. Number 7, what is the simplified form of the expression 2x to the 4th? All raised to the 3rd power. So remember, we're going to raise everything. The power of a product rule says we raise everything in the parentheses to the power on the outside. So we have 2 to the 3rd power, and then x to the 4th power to the 3rd power. We keep the base and multiply those exponents. So we have 2 to the 3rd, x to the 12th, and 2 to the 3rd is the same as 8. So we could also write our answer this way. Both answers are the same. Remember, the biggest mistake people make is forgetting to raise this 2 to the 3rd power. Make sure you don't make that mistake. Number 8, using exponents, what is the simplified form of -2 x cubed y to the 4th all squared? So again, everything in the parentheses is going to get squared, including that -2. So we're going to have -2 squared, and yes, you need the parentheses, x to the 6th power, keep the base, multiply the exponents, y to the 8th power. Again, keep the base, multiply the exponents. An alternate answer for that would be -2 squared is +4, x to the 6th, y to the 8th. Either one of those are acceptable answers. Number 9, how is the expression 5 to the -3rd written using a positive exponent? So we need to remember that the negative exponents are movers. The exponent, the power of 5 to the -3rd isn't happy in the numerator, so we're going to move it to the denominator to make it happy, and that becomes 5 to the positive third. Everything's always times 1, so technically we have a 1 in the numerator at all times. And so we have that as our answer, and that's basically the definition of negative exponents. Number 10, write the value for n that makes the equation 3 to the third power times 3 to the nth power equals 3 to the 12th power true. So when we're multiplying powers, remember, it's keep the base and add the exponents. So what I really need to do here is 3 plus n gives me that 12. I need to know what's n. You have two options. You can either know that 3 plus 9 is 12, so you can use mental math. Or we can use our equation solving skills and subtract 3 from both sides. This is especially handy if the numbers are more complicated than these. And so we get n equals 9 either way. Number 11, the volume of a drop of water is 7/10 Write the number in scientific notation. So remember, we have 3 parts of scientific notation. 1, the decimal point has to be, has 1 digit in front of it. So we're going to put the decimal point in the right spot first. So we want the decimal point after the 7 so that we have 1 digit in front of it. We can write that as 7.0, or we can write that as just plain old 7. Either way is appropriate. Now, the second part is every scientific notation is always times 10. Because 10 saves us from having to do a lot of math and moves the decimal point for us. The third part is to find the exponent. So we need an exponent for here. So we need an exponent to put here that makes the decimal point go back to its original spot up in the front of the number. So we need to move the decimal point 1, 2, 3, 4, 5, 6 places. And that's going to be 6 places to the left, so we want our exponent to be -6. So our answer, just writing it to be more clear, is 7.0 times 10 to the -6, or just 7 times 10 to the -6. Either way, those are the number written in scientific notation. Number 12, write the number 3.5 times 10 to the 5th power in standard form. Remembering that multiplying by powers of 10, multiplying by 10 moves the decimal point 1 place to the right for every 10. We have 5 tens, so we're going to move the decimal point 5 places to the right. So from here, we're going to move it 1, 2, 3, 4, 5. We fill in with zeros. Our decimal point is now at the end where we don't have to write it. So we have 4 zeros at the end. The comma is optional, but it helps us tell that that's 350,000. That's our answer, and we're done. Number 13, in 1 week there are 604,800 seconds. What is this number in scientific notation? So again, 3 steps. 1, we have to start with our number, putting the decimal point in the proper place. So we have 6.048. Remembering that we need to keep this 0 because it's in the middle of the numbers. We can't just drop it like we can the ones at the end. So we put our decimal point in the correct spot. Times 10. Every single time scientific notation is times 10. Now to get our decimal point back from here to the end of the problem where it's supposed to be, we need to move it 1, 2, 3, 4, 5 places to the right. A positive 5 is the exponent that's going to do that for us. There's our number in scientific notation. Number 14, how many times larger? How many times larger is than 3 times 2 squared, 3 times 10 squared is 6 times 10 to the 8th. So we want to know 3 times 10 squared times what number is going to give us 6 times 10 to the 8th. So what we're going to want to do is divide. 6 times 10 to the 8th divided by 3 times 10 squared. So we're going to divide numbers by numbers and powers by powers. 6 divided by 3 gives me 2 times 10. I have 6 extra 10s in my numerator, so I'm going to have 10 to the 6th power. So the number 6 times 10 to the 8th power is 2 times 10 to the 6th, or in other words, 2 million times bigger than 6 times, or excuse me, 6 times 10 to the 8th is 2 million times bigger than 3 times 10 squared. Number 15, what is the value of the expression below written in scientific notation? So again, just like our examples when we had 3a squared times 4a to the 5th power, we're going to multiply numbers times numbers and powers times powers. So in this case, we're going to have 3.6 times 3, and then 10 cubed times 10 to the 4th. So 3.6 times 3, 18, carry the 1, 3 times 3 is 9, plus 1 is 10. I have one digit after my decimal point in my problem. I'm going to have one digit after my decimal point in my answer. So the number part of this is going to be 10.8 times 10 to the, keep the base, add these exponents. So it's going to be 3 plus 4 is 7. And now my last thing is to check, is my number in scientific notation? I notice that it's not because the decimal point isn't in the right space. It needs to be after the 1 to be in scientific notation. So I'm going to move it there. I made my number smaller, so I need to make my exponent bigger. I'm going to have to move that decimal point one extra place now to get it back to its original spot. So my answer is 1.08 times 10 to the 8th power. Number 16, simplify using the laws of exponents. Write the expression using positive exponents. So first thing we're going to do, number divided by number. 56 divided by negative 8 is negative 7. Now that's not a negative exponent. It's a negative number. We don't have to do anything about that. Now we have c cubed divided by c to the 14th. Well, I can either subtract the exponents or I can use a little bit of common sense. I have 14 c's in the denominator and only 3 in the numerator, which means I have 11 extra c's in the denominator. And so that's where they're going to end up in my answer. Negative 7 over c to the 11th. If I were to do this using the division rule, I would end up with negative 7 times c to the 3 minus 8, excuse me, sorry, 3 minus 14. So I'm going to do keep, change, and get negative 11. So my exponent is negative 11. That gives me, I can't have a negative exponent in my answer, so I need to continue. So we're going to end up with negative 7, and then we're going to move the c to the negative 11 into the denominator as c to the positive 11. Either way you get the right answer, depending on, doesn't really matter which way you do it. Number 17, the game of checkers is played on a square board. The length of one side of the board is 3 squared inches. So the length of one side is 3 squared inches. What's the area of the board? Well, the area formula for a rectangle, and the square is a rectangle, is length times width. So we need to know the length and the width of the shape in order to find the area. So if it's a square, both length and width are the same. So we have area equals 3 squared times 3 squared. So we're going to keep the base and add the exponents. So the area of a checkerboard with side length 3 squared inches is going to be 3 to the 4th power inches squared. And that is our answer. Because they say write your answer using exponents. And that's it. Keep these things in mind and hopefully do well on tomorrow's test.